Acha.
Okay, let's just start.
Okay, so this paper is MLQA. It says evaluating cross-lingual extractive question answering. So this paper talks about cross-lingual question answering.
Just a minute. The
Yeah,
recording is in
sure.
progress. It's,
Okay.
it's not. Yeah, now recording is started, so you can explain this paper. MLQA, evaluating cross-lingual extractive question answering.
Yes.
Okay, go ahead.
Thank you. So this paper talks about cross-lingual thing. So uh, uh, it says that like we can do question answering on the given context in different languages. So this paper,
Yes, because cross-lingual meaning is that no different languages. So
yes,
that's why on your question might be in different language, your answer might be in different language. So multiple languages are using. That's why it is called this cross-lingual.
yes,
Okay, so it seems
yeah,
interesting paper MLQA. Let's start with this.
yes.
Okay.
Uh, okay, so it says like as you have explained this multilingual thing, and this paper have proposed a state of the art uh, model, and they have used data sets on the seven languages, that is like English, Arabic, German, Spanish, Hindi,
Mm-hmm.
Vietnamese, and simplified Chinese. So they have used the seven languages and trained the model MLQA, and then tested on their tested it and gave the state of art result. So this introduction then says that it is like NLP question answering is an important part of NLP, and different work has already been done in the
Yes,
area of.
it's like a number of literature reviews is showing. It means from where they
Right, right.
starting. What is the
Yes,
importance of the question answering, and what are other paper in similar domain and in this domain. So this all is showing in this context. So let's start. Okay.
yeah, right, right. So, as you have said, they are explaining about the different literature review that has been done. So, then the next is like they have explained about this MLQA. So, we can go through go through this paper and learn how this model is designed. So, it says
Mhm.
that this they have
It says
this
that they are
desired
making
properties for.
yes. So
Mm-hmm.
in short, we
Yes.
can say they are making two contributions. So first contribution they are making for developing a novel annotation
Mm-hmm.
pipeline to construct large, multilingual and highly parallel extractive question answers. So it's like it seems like a annotation work they are doing, and then they are releasing this MLQA model.
Mm-hmm.
And
Right.
other third contribution is they are also defining two cross-lingual question answering tasks, including novel generalized cross-lingual task, and also one more contribution is they provide baseline for state-of-the-art technique and demonstrate significant room for improvement. So okay,
Yes.
so we can is just introduction part is just like what contribution they have made and how they have made. So let's understand about this MLQA corpus.
Yes, right, right. So they have like firstly we state our desired properties for cross-lingual question answer evaluation data sets, and
Mhm.
then we note that we list some existing data set exhibiting these properties. None exhibit them all in combination. We then describe our annotation protocol, which seeks to fulfill these desired data. So this means like they are like first evaluating this uh, existing data sets, and according to their requirement, they are like trying to understand how the data desired data sets can be designed. So then they are discussing about parallel. So the data should consist of instances that are parallel across many languages, First, this makes a comparison of question answer performance as function of transferred language barrier. Second, additional evaluation setup became possible as question in one languages can be applied to document in another. Finally, annotation cost is also reduced as more instances can be shared between the languages. So they are like discussing about the parallel data sets, like the same
uh,
complexes
Parallel
in.
data set and also some kind of a transfer learning,
Yeah.
we can say, like they are saying now this makes compare this mixed comparison of question answer performances functional transfer language failure.
Hmm. Hmm. Right, right. Uh, yes. Then they are talking about natural document. In this, they are building a parallel question answer data set in many languages. Uh, require access to parallel document in those languages. Manually translating documents at sufficient scale entails huge translator workload and could result in unnatural document. Exploiting existing naturally parallel document is advantageous, providing high quality documents without requiring manual translation. So they are talking about like natural documentation means the same paragraph, what exactly the meaning is, that is done in different languages. Like instead of translating, they are writing it like naturally, just like the essay in both Hindi, English, or Chinese, Japanese, in this way. So they are creating natural document. And then they are talking about diverse language. So the primary goal of cross lingual research is to develop systems that work well in many languages. The data set should enable quantitative performance comparison across languages with different linguistic resources, languages, families, and script. So it means they are here trying to understand what is linguistic differences, and as we know, Hindi and the Sanskrit, they both belong to Devanagari script. So in this way, what is that the base, and how this uh, uh, languages have different families and which script they follow, like that. I hope is it clear?
Yes, yes, it is clear. Up to
Okay.
this, it is clear. Like diverse languages means multiple languages we are using here.
Yes, yes, yes. So next is extractive question answering. Cross-lingual understanding benchmarks are typically based on classification, and extracting spans in different languages represent a different language understanding challenge. Whilst there are extractive question answer dataset in a number of languages, most were created at different times by different author with different annotation setup, making cross-lingual analysis challenging. They are like saying that the different since it is like a supervised data set, means supervised data set, so different data sets have different annotation setup. That is why though we have data in different languages, but uh, doing a collaborative work on these data set is challenging because they have different annotations. Then is textual domain. So in this, we require naturally highly language parallel textual domain. Also, it is desirable to select a textual domain that matches existing extractive question answer training resources in order to isolate the change in performance due to language transfer. And then to satisfy this desired data, we identify the method, and Wikipedia represents a convenient textual domain, and as its size and multilinguality enables collection of data in diverse languages at a scale. So means Wikipedia is an important resource for collecting diverse languages in different languages. So it has been used to build many existing question answering training resources, allowing us to leverage these to train question answer model without needing to build our own training data sets. We choose English as our source language as it has largest Wikipedia and to easily source crowd workers. Yes,
Yes, it's like textual this thing, no? Annotation.
yes,
Sorry, can you go?
yes,
Yes.
uh-huh.
So it's like textual domain. So from where we are getting this textual information for this multilingual task. So that is showing as, yeah, we are having multiple languages available in Wikipedia, but we are selecting this English language for this task.
Right, right.
Okay.
Okay, so then is like we choose six other languages, means they are talking like they have chosen English as their source because
Mm-hmm.
it has a large data set that is available on Wikipedia.
Hmm.
And then we choose six other languages which represent a broad range of linguistic phenomena and have sufficiently large Wikipedia. Our annotation pipeline consists of the three main steps. Like they have told they are using seven languages. So first is English, then other top six which has maximum data sets available. So these are different steps for annotation pipeline. So first is we automatically extract paragraphs which contains a parallel sentence from articles on same topic in each language. And then we employ crowd workers to annotate question answer span on English paragraph. And annotators must choose answer span within the parallel source sentence. This allows annotation of question in source language with high probability of being answerable in target language, even if the rest of context paragraph is different. So, in first, they are like extracting the paragraphs that contain some content about that article in different languages, and then they have like hired the crowd worker and they are doing the annotation part and they are highlighting the portion that contains the probability of finding answer as maximum.
It seems similar, like you have a multiple language and a common sentence that is available in multiple languages. So that common sentence are extract here
Yes, right, right.
and first step, and then there is happening some kind of annotation by co-workers and other things.
Yes, yes, yes. Like this example is also here. Like this is Wikipedia article. This is in English and this is in German, and they both are like means in this the answer is annotated as this in dark where the chances of answer is there, and similarly the answer is highlighted over here. uh, the question is where is the moon located during the new moon. So the answer part is highlighted over here. Similarly, the answer part for the same question in German is highlighted then here. So they are like this doing this annotation part means highlighting where the answer can be there. So then so in this way this is the part of the step 2. They are highlighting the question. And then in step 3 we employ professional translator to translate question and to annotate answer span in target language. So they have hired the professional that who translate the question and then annotate the answer span here uh, like they have this question and similarly they are uh, getting the answer from the hired professional and then matching where it is whether the model has the answer is highlighted one or not. So this is the this three steps, and then after parallel we are going for parallel sentence mining. So It says that parallel sentence mining allows us to leverage naturally written document and avoid translation, which would be expensive and result in potentially unnatural documents. So, in order for questions to be answerable in different target languages, we use context containing an n-way parallel sentence. Our approach is similar to this wiki matrix, which extract parallel sentences for many language pair in Wikipedia, but we limit search for parallel sentences to document and the same topic only. We aim for n-way parallel sentences. Means they are extracting the sentences in all these seven languages. So okay, so to detect parallel sentences, we use Laser Toolkit, which achieves state-of-art performance in mining parallel sentences. Uh, and they have used this state-of-art Laser toolkit. Laser uses multilingual sentence embeddings and a distance or margin criterion in embedding space to detect parallel sentences. So they are using this multilingual embeddings, and then we first align all the languages with English and then intersect the set of parallel sentences forming set of n-way parallel sentences. So means they have now aligned all these sentences in different languages and then found n-way parallel sentence and found seven-way parallel sentence uh, 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 and these lack linguistic.
Seven base parallel sentences for seven language that they are using, and that's why we
Yes,
said seven base parallel
yes,
sentences. Okay,
yes,
it's fine. Like
yes,
parallel
right.
sentence, how they are mining, how they are extracting that parallel sentences. So it's all about that now.
Yes, yes. They
Okay,
have
okay.
used this. Yes, they have used this. This laser, this embeddings, and then
Hmm.
they have done the parallel K-way sentences, N-way
Hmm.
sentences for these each languages.
Hmm.
Okay, now they are saying a comparison between language parallelism and both the number and diversity of parallel sentences. We use sentences that are four-way parallel. Okay. Now they have instead of seven, they have shifted to four. This yield this 3,85,396 parallel sentences, which were subsampled to ensure parallel sentences were evenly distributed in paragraph. We ensure that each language combination is equally represented so that each language has many question answer instances in common with every other language. Except for any rejected instances later in pipeline, each question answer instances will be parallel between English and three target languages. So next is 2.2 English question answer annotation. So they have used Amazon Mechanical Turk for crowdsourcing to annotate English question answer instances, and they have broadly following the methodology of this paper. And then we present workers with an English aligned sentences like BEN along with a paragraph that contains it CEN. Workers formulate a question and highlight the shortest answer span AEN. Okay, so QEN is question and AEN is answer. AEN must be subspan of BEN. BEN is paragraph to ensure that QEN will be answerable in the target languages. Means the answer for given question must be within the given paragraph. So we include a no question possible button when no sensible question could be asked, this out of vocabulary part thing. So a screenshot of this is then shown in this appendix part. So first 15 questions from each workers are manually checked, after which the worker is contracted with the feedback or their work is auto approved. Means they are checking workers on the basis of first 15 question and then they are approving it. And then once the question and answers have been annotated, we run another task to re-annotate English answer. Here workers are presented with QEN and CEN as requested to generate A dash EN or to indicate QEN is not answerable. Uh, two additional answer span annotations are collected for each question. Okay, and then additional answer annotation enables us to calculate uh, inter-annotator agreement score. Means in first, like they were calculating this AEN that indicates the answer portion. Now they are generating A dash EN that indicates the portion where this question is not answerable. So uh, so finally we have a en and a dash en, and this help in like understanding like what is the aai score, iaa score, that is inter annotator agreement score. We calculate mean token f1 score between three answer annotations, giving an iaa score of 82%. And then rather than provide all three answer annotations as golden answer, we select single representative reference answer. In 88% of cases, either two or three of the answer exactly matched, so the majorly answer is selected. Okay, so they are like choosing the best answer. So in the remaining cases, the answer with the highest F1 overlap with the other two is chosen. This result both in accurate answer span and ensure the English results are comparable to those in the target languages, where only one answer is annotated per question. And then we discard the instances where annotations marked the question is unanswerable, as well as the instances where 50% of the question appeared in the subsequence of the aligned sentences, as these are too easy or of low quality. Finally, we reject questions where IAA score was very low. So basically, they are using IAA score to filter out filter the data and filter this English question answer annotation. Then we have this target language annotation. So in this, we use 1 hour translation platform to source professional translator to translate questions from English to six target language and to find answer in target context. So uh, they are using this 1 hour translation platform that translate the data from English to these six languages.
Mm-hmm. And this is like a target language what we are annotating. So
Yes, right.
that kind of target language question answer annotations in six languages.
Yes, yes.
Mm.
Like as we have like this total seven languages which we are taking into reference, and as we know that English data set have like highest this context available. So they have firstly collected all the English available data set, and then they have what they have done is they have like uh, done the translation in all the six languages. Then these six languages are six target languages. Okay.
Mm.
Uh,
Yeah, got it.
yes, yes. Uh, so we present each translator with English question QEN and answer AEN and context CX containing the aligned sentences BX in the target language X. So here they are like they can ask question like in any of this seven languages. So they have used X as a target language. And as we have seen, this QEN is this question, AEN is answer, CX is context, and BX is this sentences. Okay. Uh, Then translators are only shown the aligned sentences and the sentences on each side. This increases the chance of question being answerable, as in some cases the aligned sentences are not perfectly parallel. Without requiring workers to read entire context, by providing the English answer, we try to minimize the cultural and personal differences in the amount of detail in the answer. Okay, means instead of finding the solution, what they are doing, they are providing the English answer. So means as a result, the searching will be like much easier, or we can say they will be able to know that what exactly should be there in the answer. So it is like saving some time. And okay. So we sample 2% of translated question for additional review by language expert, and translators that did not meet the quality standard were removed from the translator pool and their translations were reallocated. By comparing the distribution of answer length relative to the context to English distribution, some cases were found where some annotators select very long answer, especially for Chinese. Okay. We clarify the instruction with these specific annotators and send such cases for re-annotation. Means they are here trying to do uh, this language translation in different languages by simple doing translation and providing this QEN, AEN, CX, PX, all these things. And then we have obtained the resulting MLQA corpus. So it says a context, questions, and answer spans for all the languages are then uh, brought together to create a final corpus. And they have found this final corpus. And here we can see that all these instances in each languages in this MLQA. So we have in English. In development, we have this 1148. Similarly, for this German and all such languages, we have different instances or sentences, and then the number of parallel instances between the target language pairs means the common instances this German to German and German to this, the common sentences in German and this ES. ES is ES should be, what should be ES? ES should be Spanish. In Spanish and this German, the common sentences, the parallel. So they have like number of parallel instances they have calculated for this uh, for this target languages. So finally, it says that MLQA consists of 12,000 plus extractive question answer instances in English, and all this table value is represented here. And then there.
It is just a summary of what is available in text. The table is summarized here,
Yes, yes,
explained here, not summarized.
yes,
Yeah. So I
and
think related work we should skip
okay,
because
sure. Uh-huh.
there are a number of related tasks like multilingual work. So most common task we can go through. So
Yes.
what are this most common?
So these are the related work. It simply work on this. First was on monolingual data
Uh,
sets where
Means
we have,
only one language.
yes,
Yes.
and then they had tried this cross-lingual modeling, and then they
Hmm.
have worked on few data sets, but it was not with good accuracy. Then they have like designed this data.
Data set also. Yes.
Yes, and then some aggregated cross-lingual benchmark is also
Hmm.
uh, used in this research work. Now we can like discuss about this paper experiment. So they have done is like we introduced two tasks to access cross-lingual question answering performance with MLQA. First is cross-lingual transfer, like as we have seen this target languages part. So this they are doing cross-lingual transfer, which required training a model with this C context Q question and A answer containing data in language X. So the question can be in this training data can be in any language. So this X, in our case English, development data in language X is used for tuning. And at the test time, the model must extract answer AY in language Y given context CY. Okay, so the context is CY and the answer is AY, and Y is any language, and question is QY. Okay. Similarly, as this tuple CX, QX, AX. This is the first task. Means they are doing training, and then second is generalized cross-lingual transfer. uh, it is trained in same way, but at the test time the model must extract AZ from CZ in language Z given AY in language Y. This evaluation setup is possible because MLQA is highly parallel, allowing us to swap QZ for QY for parallel instances without changing the question meaning. Okay. Then, as MLQA only has a development and test data, we adopt this squared data set as a training data set, and we use MLQA EN English as a development data and focus on zero shot evaluation, where no training or development data is available in target languages. And then this is like and these are the two steps. And then how is they are doing translation and test. We translate uh, instances from this square training set into target language using machine translation, like they have used this Google Translator. Before translating, we enclose answer in quotes. This makes it easy to extract answer from translated context and encourage translation model to map answers into single span. We discard instances where this fails with the margin of 5%. So where this is less than this 5%, so we discard those. So in this way, like they are doing the training of translated data, and then in testing, the context and the question in target language is translated in English. At test time, we use best English model to produce an answer span in in translated paragraph. In testing, what they are doing is they are translating the answer into English, and then they are checking whether uh, the answer is correct or not. And uh, for all languages apart from Hindi, they have used attention score, that is AIJ. Uh, Here, from the translation model to map answer back to original language rather than aligning span by attention argmax, we identify the span in original context, which maximizes F1 score with English span. So they are like maximizing this F1 score, this RC and PR and F1 they are calculating, and then they are doing this
This
argmax.
RC or RCPR that we are using. So this is like a precision or recall, no? That's why because
Yes, yes, right, right,
yeah, because F1 score is always calculated in terms of precision and recall.
right, right.
So it's like precision and recall. PR for precision, RC for recall. First calculating precision and recall, then we are calculating the F1 score, and then we are trying to maximize this F1 score.
Yes,
Hmm.
yes. And then this is like testing part. Then they are explaining this cross-lingual model representation, and in this they have used this zero shot transfer results from monolingual word uh, and then this model is trained with the squad training set and then evaluated directly on MLQA test set in this all seven target languages. Model selection is also constrained to be strictly zero shot using only English development data to pick hyperparameters. Okay, so means they have used a zero shot in English so that they can pick this hyperparameter, and then they are testing this learned parameters for other target languages, and then they have used this evaluation metric and then the result. So we can go through this, like most extractive question answer task uses exact match and mean token F1 score as performance metric, and then they widely use squared evaluation and also performs the following answer processing operations. The first is lowering, lowercasing, second stripping, third this uh, stripping, and the third is stripping English articles, fourth is white space to canonization. Then we introduce following modification for failure multilingual evaluation. So instead of stripping ASCII punctuation, we stripped all Unicode characters with punctuation of general category. When a language has a stand-alone articles in this four languages, we strip them. We use white space tokenization for all MLQA languages other than Chinese, where we use mixed segmentation method from this paper, because as Chinese has different uh, uh, script. So for each language means according to the scripts, this and they have different evaluation process. And then the results are shown here, and it says that this XLM has this accuracy on this different target languages, and it shows that this this F1 score an exact match on MLQA test set for cross-lingual transfer task, that is on XLT. So this has this for transferring they have shown this accuracy, as we can see that sometime this bird large has highest for English, and for Spanish this XLM, and for other languages uh, uh, different models have shown different probabilities. And then this model is finally tested on this square data set, and it has shown that this some good performance of F1 score. So this English performance, it says English performance comparison to squared using this our model, that is MLQA. So it has
Yeah,
received
so
better.
it's like we have completed this paper. Now, next discussion and all. So I
Yes,
don't think we need to discuss all these things. It's all about what already have seen in that
yes, yes, right, right.
papers. Okay, so what is conclusion here that they have introduced MLQA model and with a highly parallel multilingual question answer benchmark in seven languages. And
Right.
also they have developed several baselines for doing this two cross-lingual understanding task and also like this MLQA will help in some kind of cross-lingual question answer in future as well. So this is a hope for other things. All
Mhm.
right, so it's like a nice paper it was, and also the discussion is also nice.
Yes.
A lot of things out of this. Okay, so let's stop this.
Okay.